Video is designed as a review of linear equations. So if we're working through any of the problems on this video and you feel like, man, I don't think I've seen these before, make sure you come and talk to me right away because I'm going to go pretty fast through most of this because I'm assuming you've seen it before. So the first thing we're going to be doing is just talking about the mathematical properties that I'm sure you've talked about before. And if you're anything like students I've had, you've probably forgotten them. So I want to review just a little bit. The commutative property is the one that I think almost everybody gets right on the first try, which is order doesn't matter. For example, in multiplication, order doesn't matter. So something like 2 times 5 will give you the same answer as 5 times 2. So multiplication is commutative. The same can be true for addition. 3 plus 4 will give you the same answer as 4 plus 3. Now, subtraction, for example, is not commutative because 6 minus 8 and 8 minus 6 are not the same. Therefore, commutative in the example above only works for multiplying and addition. So commutative property, order doesn't matter for some properties. Associative is just a step above the commutative property. So for example, if I'm doing, the 4 times 6 equals 6 times 4, that's commutative. But if I add in a 2 right away, and I add in a 2 to this side as well, this is still true. Therefore, this is an example of the associative property. The example can still be true for addition as well. So 1 plus 2 plus 3 is the same thing as 3 plus 2 plus 1. That the order still doesn't matter for some operations. The identity property, I call that the mirror property, which means the number is looking in a mirror and both sides of the equation are true. So for adding or subtracting, 0 is what makes the mirror. Also, if you did it 4 times 1 equals 1 times 4, still true, like looking in the mirror. Another example here with subtraction, if I did 4 minus 0 equals 4 minus 0, still looking into the mirror. You can also write it like that. So that is the identity property, or I call it the mirror property. And finally, the last one, and probably the hardest of these to remember, is called the distributive property. And in order to be using the distributive property, you need parentheses. So for example, if I had something like this, what the distributive property says is that if I do this the long way, so I do 6 plus 8, which is 14, and then I did 3 times 14, I get 42. However, if I do the distributive property, I distribute the 3 into each number and multiply, I get 3 times 6 plus 3 times 8. So I get 18 plus 24, which is still true. So the distributive property really is just a shortcut of something you can do the other way. But if there are variables included, the distributive property is the only way to solve the equation. So that was just a really fast review. And while we go on, before we go on to actual examples, I want to just talk about why do we solve equations the way that we do. And what we're doing is we're focusing on keeping a true statement. So if we look on the left here, 6 equals 6 is true. And if we draw a line down our equal sign, which is what I always do, and we think of this as a balance or a scale, we want both sides of the scale to remain equal. If I do something to one side of the equation, let's say I multiply by 3, as long as I multiply by 3 to the opposite side of the equation, this is still true, because now I have 18 equals 18. If I subtract, let's say 6 from both sides of the equation, that is still a true statement. So the goal of working through equations is you want to do the same operation to both sides of the equation. That will make the equation continuously true, and then you can solve for the missing value of x. Over here, the same thing can be said for division. So if I divide both numbers by 2, I would get negative 2 equals -2. Still a true statement. And if I do something that's different to both sides of the equation, let's say I multiply by 3, but on this side I multiply by -3, I get -6 equals +6, which is now false. And it means I've made a mistake. So you're trying to make sure the equation is always a true statement, mainly by looking at something like the commutative property or the identity property, sometimes the distributive property as well. So let's break down into some examples. So as we work through these problems, the first thing I always do is I draw a line down the equal sign to tell me that I have to do the same thing to both sides, which means I cannot do 2 operations to this side without doing the same 2 operations to the opposite. We find the variable, which in this case is n. Whoops, probably want a pen, which is n. And I want to look at what number is farthest away from n on this side of the equal sign. Well, the 4 is very close, so this looks to me to be the +8. And the opposite of +8 is -8. And I have to do that to both sides of the equal sign. When I draw a line here, it tells me to reset the problem. Well, +8 and -8 are equal to 0, so we can ignore them. Then I would do 4 times n, which is the thing that's left on this side. -16 minus 8 more is -24. And now I just do the problem again. I think 4 times n, the opposite of multiplying by 4, is dividing both sides by 4. Now there's 2 ways to write this. I can do 4 divided by 4 is 1n. Or I could write just regular n, because 1n and n are the same thing. Then I do -24 divided by 4, which is -6. So n equals -6 as my answer. Now, you can get a piece of candy for coming up to me saying, right now, you must always check your answer. If you are on a quiz or a test and you do not check your answer, I will not give you any credit for the problem. So 1 piece of candy for coming up and saying you must always check your answer. To check your answer, you just make sure what you did makes a true statement. So I substitute in -6 for my n, then I get 4 times -6 plus 8, and it must equal -16. -24 plus 8 is equal to -16. Therefore, this is true. And we have checked our problem. And that's the basic review of equations. Let's get a little bit harder here. We have 3 parentheses 2x plus 5 equals 27. So now we have the distributive property. And since we have an x inside of the parentheses, we have to do the distributing. Now, what the distributive property really means is that you are doing 3 groups of what's inside the parentheses. So what you're really doing is 2x plus 5 plus 2x plus 5 plus 2x plus 5. But nobody wants to write it that way. So instead, they will do 3 times 2x, which is 6x, and 3 times 5, which is 15. And he set that equal to 27. If we look up here, we would get the same thing, 6x plus 15. Now I'm going to draw my line down the equal sign, and I'm going to solve this exactly like I just solved the last problem. The number that is farthest away from the x is the +15, so I'm going to subtract 15 from both sides. I've now done that twice. 15 minus 15 is 0. So on the left side is just 6x, on the right side is just 12. From here, I can divide both sides by 6. This time, I'm going to draw it like that. 6 divided by 6 is 1x equals 2. And now I check my answer because I'm required to. Now, this time, the check's going to look a little bit different. Because I did the distributive property last time, now I can just do this regular without the distributive property by doing 2 times 2, which is 4. 4 plus 5 is 9. So I have 3 times 9 equals 27. That is true. Therefore, I have now gotten the right answer for both of these problems.